Okay, hello everyone, and welcome to our first lecture in the Introduction to Engineering course. This is the first real lecture anyway. I'm your professor for this class, and my name is Dr. Tom Hooten, and today we're going to embark on what I hope is going to be an amazing and exciting journey to explore what engineering is all about. This class is the only class that's required for all engineering majors at TJC. After this class, the engineering disciplines diverge, and depending upon which discipline you pursue, you're going to have differing course requirements than others. All right, so maybe you've always dreamed of being an engineer, or maybe you're curious about what engineering discipline interests you the most. But regardless of why you took this class, I'm thrilled to have you here. So let's get started. Let's start with a deceptively simple question. The question is, what is engineering? Okay, the simplest answer to this question is to say engineering is what engineers do. And while that's not wrong, it also isn't very helpful to us. The problem is there's really no perfect definition of what engineering is. Now, I am someone who has worked at a job where I had the title of engineer. I worked 13 years as a software engineer. In fact, when I quit that job to take this one here at TJC, my title was Senior Engineer 2. And one of my responsibilities was to teach a class as an engineer for newly hired engineers of varying disciplines. So I am of the opinion that defining the term engineer or engineering is harder than you may first think. My problem with defining engineering is that it is such a broad term as a job description. So I did a little experiment. I asked ChatGPT to help me define an engineer. And I did it like this. I gave it a prompt and I said, give me a list of words or phrases that are synonymous with engineer. And here is what it generated. You can see it there. Planner, creator, problem solver, designer, innovator, builder, maker, fixer, craftsman, organizer, inventor, constructor, troubleshooter, tinkerer, strategist, improviser, visionary, or doer. Now, this list it's a good list, okay, but let me show you why it is a problem to come up with a perfect definition. First of all, take one of these terms. Let me turn on my pointer here, and let's say we take this term problem solver right here. Okay, a lot of people see engineers as problem solvers, which I guess is true, but aren't plumbers also problem solvers? I mean, when a toilet is stopped up, that is definitely a problem. And a plumber can fix that kind of problem. Does that mean that a plumber is an engineer? Or is an engineer just a glorified plumber? Or, okay, pick another one. What about a designer? Well, is someone who designs clothing or someone who does interior design, is that an engineer? Or take the term builder. Okay, well, is a carpenter then an engineer? You see how it goes. In fact, for every definition you come up with for engineer, you can probably think of exceptions to that definition. And here is the point. There is a difference between someone who does engineering and an engineer. Okay, there's a difference between someone who does engineering and someone who is an engineer. A plumber, for example, may do some engineering as part of their job, but they're probably not an engineer. So let's talk more about that. That says what I just said. There's a difference between someone who does engineering and an engineer. Okay, let's play a game. The name of the game is it an engineer or is it someone doing engineering? So the idea is I give you a name and you tell me, is that person an engineer or is that person someone who is doing engineering? And let's begin with this guy, Elon Musk. Okay, which is he? My opinions are he is someone doing engineering. He is not an engineer. Why? Because Elon Musk, even though he's heavily involved in engineering work at companies that he owns, like Tesla or SpaceX or others like that, he does not have a formal engineering degree. That in and of itself doesn't disqualify him, but as being an engineer, but he does not have the formal engineering degree. His background is actually in physics and economics. And while he applies engineering principles to his various ventures, he is not a licensed engineer by any means. Okay, who's next? What about Jeff Bezos? He is the owner, founder of Amazon. He is just someone doing engineering. Now, here's the thing. Jeff Bezos studied electrical engineering and computer science at Princeton. So he's got the degrees. But he's more known as an entrepreneur and a business executive. He works at Amazon, and he owns Blue Origin, which is another space company that takes people into space. Even though he's involved in those and overseeing many of those engineering projects, he isn't typically the one engineering the solutions directly. So he falls more into the category of someone doing engineering. Okay, here's another one along the same lines. What about Mark Zuckerberg? Again, someone doing engineering. Mark Zuckerberg is a computer programmer and an entrepreneur. He studied computer science at Harvard, but he didn't complete his degree. And his work on Facebook involves a lot of coding and technical work that you might consider to be software engineering. But he's not a trained engineer by formal education or profession. He's not licensed in that sense, so he fits into the someone doing engineering category. Okay, what about Thomas Edison? Again, someone doing engineering. Thomas Edison, he was a prolific inventor. He applied engineering principles to his work, but he didn't have the formal training in engineering, and his approach was more experimental in nature. He relied heavily on trial and error, and not an understanding of first principles. So that places him into a category of someone who's just does engineering. Okay, here's a couple, here's one, Jamie Hyneman and Adam Savage. Those were the two guys that hosted Mythbusters. Okay, so they're well-known figures that did experimental type engineering things on TV. He's done a lot of, him and Adam Savage have both done a lot of practical engineering work, particularly in special effects, experimental builds and such. However, he doesn't have a formal engineering degree. He's not necessarily always practicing engineering principles. So he and Adam Savage are both people that are doing engineering. Okay, but there was another person on that show named Grant Imahara. Now, Grant was one of the young people on the show, and he died of a brain aneurysm. I think he died in 2020. I forget the exact year, but it was sometime in there. But Grant was a trained electrical engineer. He had a degree from the University of Southern California. And he worked as a robotics engineer at Lucasfilm's Industrial Light and Magic division before he became a co-host on Mythbusters with Hyneman and Adam Savage. So his work involved there, he was designing and building complex electronics and robotics systems, which places him squarely into the category of engineer. Okay. All right, let's move on. What about Nikolai Tesla? He's an engineer. He did not complete his formal education. But he had a very profound understanding of the applications of engineering principles, and he applied those to electricity and electromagnetism. In my opinion, it makes him an engineer. His innovations in AC power, electrical engineering, were based on rigorous scientific methods. He used the principles of engineering. That places him pretty firmly, in my opinion, in the area of engineer. Okay, some may argue with that, but that's my opinion. Okay, what about this guy, Bill Nye? Bill Nye the Science Guy. Okay, Bill Nye the Science Guy has an engineering degree. He's actually a mechanical engineer by training. He holds a degree in mechanical engineering from Cornell University. And he worked as an engineer at Boeing before he became a science communicator. He became TV personality science guy. So it's his background and his career that make him an engineer. Okay, let's move on. What about Steve Jobs or Steve Wozniak? Let's talk about Steve Jobs. Steve Jobs and Wozniak were both co-founders of Apple. Jobs, though, was the visionary guy. He was the driving force behind a lot of technical innovations, but his expertise is more in design and in marketing and vision, product vision for the company rather than engineering itself. Now, he worked closely with a lot of engineers like Wozniak, but he didn't have a formal engineering background, which makes him someone doing engineering. Okay, what about Wozniak then? Well, he's an engineer. He is also, like I said, the co-founder of Apple. He was the technical brain behind the early Apple computers. When he invented Apple, he did not have an engineering degree, but he went back to UC Berkeley. He completed his degree in electrical engineering and computer science. But even before that, he was essentially doing the job of an engineer, using engineering practices. So even though it's kind of a gray area to say whether or not he was an engineer or not at the time, he did become an engineer. Like I said, he got a degree in electrical engineering and computer science. And by the way, he now has 10 honorary doctoral degrees in engineering from various universities. Okay, here's another set. What about Bill Gates and Paul Allen? Well, Bill Gates and Paul Allen, these were the co-founders of Microsoft. And Bill Gates was a computer programmer and an entrepreneur and, one of the richest people in the world. But he dropped out of Harvard to start Microsoft, and he played a key role in developing one of the first important operating systems for personal computers called MS-DOS. DOS stands for Disk Operating System. Okay, so it's Microsoft DOS. And then that went on and became Windows later on. So while he has done a lot of technical work, he doesn't have the formal engineering degree, and he's categorized, in my opinion, as someone doing engineering. Okay, well, what about Paul Allen then? Well, Paul Allen was an engineer. He was a co-founder of Microsoft. He had a strong background in software engineering. And he was instrumental in developing DOS, the early software products that Microsoft generated. And despite not completing his formal education, his technical expertise and engineering contributions, in my opinion, qualify him as an engineer. Okay? So, as you can see, there is a difference between someone who is an engineer and someone who is doing engineering. So, we need a definition now. Here is going to be our working definition of engineering. And as with all things in science and engineering, it is subject to change as new information becomes available. But at its core, engineering is the application of science and mathematics to solve problems. Okay, with that as our definition, then it may be, if we go back and look again at some of those people in that list, they may cross over into the engineer category. Okay, but that's a judgment call. It's a judgment call one way or another. A lot of professional organizations recognized that it was becoming a problem early in, say, the 20th century. And they laid out a nice set of rules and requirements for what it takes to be an engineer. We'll actually talk about those probably next week. But it's a little more clear whether or not a person is an engineer here in the 21st century than it was for, say, like Nikola Tesla back in his day. Okay? This is our working definition of what engineering is. It it is the application of science and math to solve problems. So what do engineers do then? They take ideas from some concept to some reality. They create some kind of product, usually, whether or not that product is something physical or software. It's usually a product that is delivered to a customer. They may design it, they build it, they may maintain it. It could be a structure. Doesn't matter what it is, whether it's constructing a bridge or developing new software or creating renewable energy resources. Engineers are problem solvers at their heart. So the thing that separates an engineer from, say, a plumber isn't the degree or even the pay. It's the level of analysis, specifically the mathematical analysis. The study of something like laminar and chaotic fluid dynamics flowing through a pipe, as opposed to a master plumber whose job is still important, but it doesn't require a good understanding of things like fluid flow or fluid velocities and pressure gradients in the walls of Schedule 40 pipe in a gravity sewer system or something like that. All the plumber needs to know is that for every foot of sewer line, the pipe needs to drop 1/4 of an inch. Okay? So there is a difference between the level of analysis there. All right, moving on. So engineering is a pretty broad field and encompasses a lot of disciplines. You're probably familiar with civil engineering, okay, which involves designing and building infrastructure, things like, roads and bridges, but a lot more besides that. Mechanical engineering focuses on machines and devices, anything from automobiles to robotics to rockets. Electrical engineering powers our world with everything from the phone that's in your pocket to power grids. And chemical engineers, well, they work with processes that involve chemistry and chemicals and pharmaceuticals and materials. Those 4 engineering areas, those 4 engineering disciplines are considered the pillars that make up the foundation of all engineering. But there are lots of other disciplines today in modern engineering. If you go to Wikipedia and you type in list of engineering branches, there are literally hundreds, possibly thousands of engineering branches and specializations that will pop up. Okay. Now they won't be in a nice, neat list. You'll have to go through that, but you can find them. Where did all this engineering stuff originate? I mean, everything has a history. Who invented engineering? When did it all start? Well, again, it's not as simple as you might think. And the reason it's not as simple as you might think is because engineering has been shaping the world for literally thousands of years. So that means it deserves a few minutes of our time so that we can devote to the history of engineering, so that you, a future engineer, can see where you came from. And we'll cover only a few of the major milestones that have transformed the world. And we're going to divide things into categories. We'll start with ancient engineering. We'll go to medieval and Renaissance engineering. You can see the time that we're talking about. And these times are very approximate. The first industrial revolution, which was from the late 18th to the, I should say early, it says earth, but it should be early 19th century. And then the second industrial revolution, which is from the late 19th to the early 20th. And then the third industrial revolution, you didn't know there were so many, did you? Mid 20th to late 20th. And then the fourth industrial revolution, which is the 21st century. Okay, remember, this is a quick overview of the history of engineering. There are actually complete volumes of texts and complete courses taught about each one of these eras. Let's start with the early days of engineering, when human ingenuity was first taking off, okay, and began to shine. Let's look at this picture first. Now, imagine that you're sitting there in the middle of the desert, you're staring up at the pyramids of Giza. These things are ancient and they're just massive, okay? I mean, how did a bunch of ancient Egyptians with none of the fancy tech that we have today manage to stack all those super heavy, gigantic stones into perfect pyramids? Was it aliens? No, it wasn't. Turns out, though, they had secret weapons. They had something called, well, something that we call simple machines. You ever hear of that? You ever hear of ramps and levers? Yeah, those things you probably learned about in school somewhere along the way, but probably never thought twice about them. But ramps let them slide these huge stones up to higher levels, and levers then help them lift and nudge the stones into place. And when you have a lot of free labor, maybe in the form of slaves, then you can accomplish great things like building the pyramids. It's pretty wild to think that something so basic as levers and inclined planes were the keys to building one of these oldest structures in the world that has lasted till today. All right, now let's head up to England. Okay. Behind my picture here, these are some stones from Stonehenge. You've probably heard of Stonehenge. Those stones are massive, and nobody really knows why Stonehenge was built other than it was probably of some religious significance. But dragging those stones, those huge stones across the country, because these are not local stones, they came from other places. And so they had to be shipped in, and they didn't have trucks, they didn't have cranes. So how did they do that? They used logs or rollers or good old wheel and axle tricks and levers, of course, to put these stones into place. And you can picture a bunch of Neolithic people just muscling these stones into place using nothing but wood and rope. And it's really kind of awesome. And they were doing some serious engineering without even knowing what engineering was at the time. Now let's jump, say, to Rome for a second. The Romans, they were engineering masterminds. What you're seeing here are called aqueducts, for example. These things are like the superhighways for water. They stretched for miles. And what they would do is they bring fresh water right into the heart of the city. No pipes, no pumps, just gravity doing its thing along these waterways that they built. And finally, let's talk about the Great Wall of China. This thing stretches over 13,000 miles. It goes through mountains and deserts and everything in between. And it's not just a wall, it's a massive feat of engineering. But here's the thing, they didn't have fancy tools, but they knew how to work with what they had. Simple machines, pulleys to lift heavy stones, ramps to move stones up steep slopes, and good old-fashioned manpower. It's the same story across all of these ancient wonders. You know, simple machines, brilliant minds, and a lot of determination. Okay, these are the 6 simple machines. The lever, inclined plane, wedge, pulley, wheel and axle and screw. And here is drawings of each of those. There's 1, 2, 3, 4, 5, 6. Okay, this is the wheel and axle. It's a round thing that is rolling up the rope, and you can turn it over here and you can draw water out of a deep well like that. Okay, those are the simple machines. All right, but what do? They are force enhancers. That means they either multiply the force, or they change the direction of the force, or they increase the distance over which the force is applied. So you can see the inclined plane here. Rather than you having to lift the barrel straight up, you can push the barrel a little bit at a time up the inclined plane. So the amount of force that it would take to do the lift over this short distance here is now spread out over this great longer distance, which makes it easier to push the barrel up. Okay, this is a lever. Here's the fulcrum. You can see it's hanging from that fulcrum. It's not like a crowbar, the way we normally think of as a lever, but you can see it's holding a heavy weight here with just a small weight over there. So a little bit of force on the left-hand side allows you to lift a big, much heavier thing on the right-hand side here. This is a wedge. You can see it's splitting apart the wood. This is a pulley that changes the direction of the force. This is the wheel, and this is a screw. You can see the screw not only can be used to hold things together, like you can screw pieces of wood together, but it also could be used to lift things. A screw is nothing but an inclined plane wrapped around a cylinder. All right, so let's begin our history lesson then after the ancients. With the downfall of the Roman Empire, which, happened around 476 AD, so before 500 AD, there was little advancement in engineering. So by the time we get to roughly 1000 up to 1600, this is the period called the Middle Ages, what some people would call the Dark Ages. Now, it's called that because there wasn't a lot of intellectual advancement. But one area that did advance was replacing human or animal labor and using existing forces of nature to provide forces and act as motors. For example, instead of having an animal walk around and grind up the mill or the seeds or the wheat or whatever is being ground there, instead of doing that, we could have windmills. Okay, the wind turns the propeller of the windmill, and then that causes the stone to grind there. You could also do the same thing with the water wheel. So windmills and water wheels were developed, and they harness natural energy to perform tasks like grinding grain. Now, there were other advancements during that time, paper milling, printing press, the first universities, advances in military technology, things like steel crossbows and armor, chainmail, and things like that. Okay. Something else important that developed during this time period was an advancement in math. While Europe was going through its dark ages, the Middle East was during its golden age, the Islamic golden age. So the Islamic golden age brought us algebra and laid the foundations for modern engineering with scholars like Al-Khwarizmi. This was a big step in math, and it advanced knowledge of mathematics, but to be honest, that would not see big impacts into the world of engineering until much later. But when the Renaissance began, geniuses like Leonardo da Vinci, they designed flying machines and other innovative devices that were way ahead of their time. So while we're in this period and we're talking about this, let's talk about the term engineer. The term engineer has its root in a Latin word, the Latin word ingenium. It's the same root as ingenuity or ingenious. And it was usually referred to a person who was a clever person, considered a problem solver. So a clever problem solver was an ingenium. But it was during this period of time, around the 12th and 13th centuries, that another term, an ingeniator, was first used in Western Europe. And it was a term used to describe someone who was responsible for designing and building military engines, or siege engines. Now, that would have been things like catapults or trebuchets or battering rams or siege towers. They were the war machines, and they were used in battles and sieges. Now, this is the term that eventually goes on to become the term that we know today as engineer. In fact, for ages, engineers were considered military engineers. You built the machines of war if you were an engineer. You didn't even need the term military in front of it. If you were an engineer, you were considered someone who built the machines of war. But now let's fast forward to the late 18th century. And we enter the first industrial revolution. This era was defined by the mechanization of industry. Now, a lot of things happened during this period, but one of the most important things was steam engine, the steam engine. But we have things like textile production that can take place. We have steam power. We have iron making, smelting. We have tooling machines. We have the chemical industry. We have concrete production. We have gas lighting. We have mining. We have canal waterways that need to be built, railroads, roadways, agricultural production. And all of this, for good or for bad, could not have happened without the involvement of engineers. Engineering was absolutely necessary for this industrial revolution to take place. But it was during this time period that the term civil engineer became popular. Remember, an engineer was a military term, but by adding the term civil before it, it makes it clear that this is a type of engineering that is civilian in nature. It's not military. Civil engineering came into being with the construction of bridges and railways and roadways. And those were things that connected cities and it fueled urban growth. So cities began to grow and become major centers at this time. So the second industrial revolution brought even more changes, and it was driven by electricity and the internal combustion engine. These two things allowed for the invention of mass production then. So Thomas Edison's invention of the light bulb, you can see him over here, and the widespread use of electrical power. It transformed industries and it transformed homes alike. This era also saw the birth of the automobile. This is Henry Ford and somebody else whose name I forget. Also, the Wright brothers, the first powered flight. So electrical engineering flourished with the development of the telegraph and electric motors, and it laid the groundwork for the modern world. And mechanical engineering with the development of combustion engine, that became largely a mechanical engineering world as well. Then we come to the third industrial revolution, which is also known as the digital revolution, and it began in the mid-20th century. And the thing that sparked that was the invention of the transistor in 1947. And the reason that that was important is because that was the thing that led to the development of the computer, which has since become integral part of every aspect of modern life. You're looking at a computer right now. Automation, robotics began to take hold in manufacturing. The automated assembly line became a robotic assembly line, essentially. And then space exploration also became a reality, and it reached new heights with the Apollo missions. Hopefully we can go back to the moon someday before I die. But this period here that we're talking about, this was the digital age. And it's setting the stage for what is to come, for the interconnected world that we live in today. And that brings us now to the present day, the fourth industrial revolution. This era is defined by a fusion of a bunch of different things. First of all, the physical, the digital, and biological technologies. We're talking about AI. We're talking about the Internet of Things. That's what IoT stands for. We're talking about robotics here, which can be used in a number of ways, including military. And we're talking about big data. These technologies are transforming the industries, they're transforming the world one more time, and at an unprecedented rate. For example, AI. AI is making decisions in real time in some places, in some industries. The Internet of Things, the devices that are connected, they're connecting our homes, they're connecting our cities. And of course, 3D printing is revolutionizing the way manufacturing occurs. But with all of these advances come challenges. There's going to be ethical concerns. We'll talk more about ethics in this class as well. There's going to be job displacement. And the jobs of the past are not necessarily going to be the jobs of the future. And also it brings up the need for something that was never important before or considered important before, and that was cyber security. It's really important these days. So engineering isn't just about building bridges and designing machines. It's a discipline that applies to virtually every aspect of human life. Just look around you. Look at the paint on the wall was engineered. The walls themselves were probably engineered. The clothing that you have on was engineered. So it's everywhere. Okay, well, what about agriculture? Today, precision agriculture uses things like GPS and sensors to optimize crop yields and minimize the use of resources. If I can get the water straight on the plant, I don't have to water the whole field. I can just water that plant. Robots can do that. The area of warfare, there is still an Army Corps of Engineers. In the modern era, though, advancements in aerospace engineering have led to things like drones and missiles. I don't know if you care, but one of the things that I follow on Reddit is the Ukraine war, and I can see that a large part of that war is being fought with drones. So that sort of thing has refined military strategy. Also, materials, innovations such as carbon fiber, composites, and graphene, they're transforming materials industries. And it's enabling the creation of more efficient things like vehicles. If you can make a vehicle a lot lighter, then maybe you can run it on a smaller battery. Make it more resilient. Make a more resilient infrastructure. If you could build bridges out of composite materials, and even you can use materials to store energy. Okay, so different forms of energy storage. So engineering, bottom line, is a universal thing. It's a universal language, in fact, and its principles can be applied to solve problems in pretty much any field, whether it's agriculture, warfare, or the buildings we live in, or the clothes we wear. Engineering is at the heart of human progress. Okay, now this is an introduction to engineering class. So that overview that we just went over was very superficial. I understand that. But if you care to investigate more about the history of engineering, there are a lot of resources available. If you're interested, you can find those resources. Let's review for just a second here. The history of engineering is about problem solving all the way down to the most ancient times. And hopefully you noticed that each of those revolutions that we discussed, it came about because of some sort of innovation. The steam engine revolutionized industry. And then the electric motor and the internal combustion engine revolutionized industry. And then the computer and the digital age revolutionized industry. Well, now we're at the point of a new revolution, and this is the fourth industrial revolution. And that's the AI-driven combination with biological sciences that are going to change the world, to be honest. I think it will change the world in almost no time. So from ancient pyramids to AI-driven smart devices, you got the history of engineering all summed up right there. And what is common? Human ingenuity and a drive to push boundaries. So look to the future then, what do we see? Well, engineers are going to continue to be at the forefront of solving the world's biggest challenges. So you get to make up your mind. What role are you going to play in the next chapter of what is going to be an incredible story? All right. Now, you have some assignments for this material. First of all, there's a discussion post where the instructions are in the weekly assignment message. You should look at that. But it's a discussion post about a famous engineer. Go find a famous engineer. Don't find one that somebody else has already found, so you might want to look through the discussion post first before you make your decision. And then you also have a weekly quiz over the material that's covered here in this lecture. All right, moving on. Next week, we will pick up and cover a new topic. We'll talk about engineering curriculum. We'll talk about how a person becomes an engineer. What is the process? Because it's not a simple process, but we'll talk some about it. Y'all have a great week, and I'll see you online.